Welcome everybody to the next session from Narrow Research. I'm Srijit here. So we are continuing the applications of QE using AMS GUI. So in this session, we will be focusing on a lattice optimization of silicon interface using QE. So let me go to this. Lattice. Okay. So here in this demonstration, we are focusing on lattice optimization. We will make some slight changes in the lattice to move the atom away from the equilibrium. However, to ensure that the system symmetry is maintained throughout the optimization process, we will change the lattice vector length instead of the component directly, and we will allow the automatic adjustment of the atomic position in response to the changes in the lattice vectors. So there is an option in periodicity. So you can see at the right hand side. So in this session, we will be focusing on how we can set up the calculations input before the calculations and how to do the basic calculations using this interface. So in the main panel, you can see the periodicity. I'm just selecting the periodicity here, and then I'm activating the automatic adjustment to the atomic position by changing the lattice vectors in the adjust atom checkbox. You can see that this is the thing which I have discussed, and the lattice vector length to 4. So let me adjust it to, and after adjusting it, and then I'm going back to the main panel. So why adjusting the vector lengths before allowing automatic atom adjustment will result in the undesired atom coordinates updates, which leads to broken symmetry, and this broken symmetry will induce wrong results on certain properties like band structure. So then we will be focusing on setting up the calculation. So here, let me go to the main panel. So you can see that what are the different tasks we can perform here in our QE interface. We can do job to optimization, molecular dynamics, NEB, potential analysis of a scan, a single point energy calculation, transition state calculations, vibration analysis. So we will be discussing each and every task step by step in our tutorial videos and the discussions. So the next webinar will be on the applications of quantum espresso in our interface. So we will be focusing on it on a brief and descriptive way. So here I'm just going to select the geometry optimization task, and then this lattice optimization parameter I'm going to activate, and then we are going back to the main menu, main tab. We also need to set up the general calculations options. So in this case, we will leave most options as the default values. For example, we will have to check the results are converged with respect to the k-point grids and wave function energy cutoffs. So starting from AMS 2024 version, we have an option to use pseudo-potential families, which significantly simplifies the process of selecting the pseudo-potential. The pseudo-potential that best fits the requirements. The three options that follow pseudo-potential title work as a filter. So this is actually pseudo-potential function and the family. So these are the options in this library. Again, if you want to focus on main potentials, we can see what's the pseudo-potential used for silicon atom. So, the options which follow the pseudo-potentials title, which works as a filter, all pseudo-potentials from the pseudo-potential directory that are available for the elements of the specific system of our choice. So by choosing options family, functional, and fully relativistic, we narrow down the list of available pseudo-potentials. So this is actually the thing which I have just focused. And this is the pseudopotential family, pseudopotential functional, and full relativistic. Okay. And then if you want to focus on more about the family, we will be conducting a technical session on this specific case. So now let me select this pseudopotential, and so this is just an example, and we will need to determine that through the calculations which pseudopotentials are best suited for our specific work. So right now I'm not changing anything, just leaving it as default, and then I'm going to adjust the K points. So the K space family for some recommendations in QE. So just now I'm setting it to 10, 10, and 10. And so this is actually the basic calculations for this, the general inputs for lattice optimization. And then I'm just saving it. So just save as, because I have already executed the calculation here. So just silicon underscore geo. So I have already saved that earlier. So that's why I'm just renaming it as geo1. And so here we can go back to the periodic view and also the normal view. So let me run the calculation. So you can see the progress of this calculation. It will take some seconds. So you can see that the calculation has started, and if we take the log file, we can check the progress of the calculation. It has started, and it will take some time to finish the process. So for time being, I have already run the calculation, so I'm just killing the job here, otherwise it will take some time. So what would be the output? So I'm just going to the AMS movie to show you the digital, the animated representation of the calculation. And just focusing on the graphical representation and the lattice vector length to vector 1. So it will give an idea that how the step-by-step progress of the optimization is happened using the lattice optimization. So you can see the progress. So that's all for the intro video on lattice optimization, how we have created the inputs, setting up the default setups in that interface. And in the next session, we will be focusing on what are the more applications which we can focus on using the quantum Espresso interface. Thank you.